Okay. What would probably benefit you is opening to page 110 or 110. Okay? 110. Okay? And on a maybe a blank sheet of paper that would look like this, or has no lines on it, or a notebook paper, which is fine. We're going to put the slide rule on there, and you're going to want to make sure that you don't write it small. I mean, it's going to be hard for you to use. So don't be afraid of taking up the whole page, okay? There's absolutely nothing wrong with that. And when you do that, it's probably going to make things a lot easier for you should you choose to do that. And once we get going, you're probably going to say, oh, I do remember this now. Yes, this is a tool, but you don't write examples on there. You don't write let's say, I would say classified information. We're not, this isn't what I'm looking for, but we don't want a material on there that would make it unfair for everyone else, okay? Do you just want me to write these down, or you want to try to put them down how you remember? Try to make this big enough so that you can actually still see it. And if you look at some of these examples, going through some of these videos that we do, is there any color that does not show up very well that you've noticed if you've gone through and watched them? Because I've noticed this does keep track on how many views have actually gone back and watched some of the general chemistry videos. I noticed there's like one or two, but there's been no issues with I can't read that. Okay. And notice the sound probably wasn't very good back then, but now we got this handy dandy microphone that works pretty well with administering the sound now. And you'll notice that when you see the term periodic table, this is why it basically gets its name for that, because what do you notice is happening over and over again. It's repeating itself. Okay, so that's what we mean by the days of the week, the months of the year. It's a period that keeps repeating itself. Okay. Have we had enough yet? Are we having fun? Do we stop there? No. Let's keep going. We got to do a little bit more. Oops. It is. There we go. Okay, now you have to have that ability to draw straight lines. So if you need a ruler, we can certainly, I think I got a ruler in that desk. Otherwise, just freehand it. That's why you have all this space so that you can do this now. And if you remember right, what did we call this? The slide rule, because these represent slides on how these orbitals fill up and in the order that they do so and how many they actually can hold. There's not a 7D. Nope. So when you look at your periodic table, it's once you get a very good understanding of how to use that table, you probably don't need to use this anymore. Okay? But but you got to be able to use the two in conjunction. You can't just rely totally on this to do how electrons interact with one another and how they fill different models, because when it comes to reactivity, okay, for instance, it's one of the Safe Light commercials where they're talking about how this individual comes to, it looks like a middle school, and talks to, and she's a science teacher. And at the very end, where he's driving away, they're about to do an experiment, and it's probably one of the most common ones when it comes to perhaps a science fair experiment. Yeah, baking soda, acetic acid, or vinegar, volcano. And it's when you mix those two together, it's the electrons that interact with one another that determines an element's reactivity. Because, for instance, when you were completing your exam yesterday, there was something very significant we wanted you to do with the element copper. Does anyone remember what that was? It said draw how many electrons are in the element copper with a +2 charge. I think everyone got it right, so you hopefully can tell me right now. Look at copper, element 29. It has 27. That's right. Because, okay, now very quickly, we're just going to show you where that comes from. Because inside the nucleus now, it's element 29, remember. So we've got two. What happens when you add all them numbers together right now? It's going to be 29, because we've got 10, 18, 20, 29. But we said copper with a +2 charge, which means this is neutral right now because we've got 29 positive charges and we've got 29 negative charges. So if this is going to form this ion, what must happen then? It's going to lose something. It's going to lose 2 electrons. Okay? And what happens is these 2 electrons disappear. This shell is still here, but it's just empty. So now when you add all these together, you're going to get your 27. There's 10, there's 18, plus 9 gives you 27. And that's where that comes from yesterday. Okay? So the last thing, and some people, we didn't put the little exponents on here because I sometimes think that confuses people. So rather than me writing it, I'll let you make that choice. So when you look at page 110, that table, I believe it's telling you the number of electrons that each shell or energy level can hold. So when you look at, this is table 2, the first energy level, then you look to the far right, number of electrons per, next it says number of electrons per sub level. Okay, so what that means is first energy level, this is the sub level, and how many can the s orbital hold? 2. And does someone have their periodic table handy? Dig. Oh, it's right on top. Awesome. Okay. So what we see happening here, I suppose I could have held up a periodic table out of the book, is that what we know, this is where it's coming from. Okay? These are your s orbitals right here, columns 1 and 2. And Tom, you can answer this question. What does it say right above helium and lithium and beryllium? S block. Do you suppose that's a coincidence? No, it is not. columns 1 and 2 are located right here in the S block, okay? In other words, here's hydrogen and helium. You might say, well, helium's not in the first or second column. While that's true, that's why when you look on this periodic table that you see helium detached from the rest of the noble gases. What does it say above helium? See, helium is still part of the S block. Because how many protons does helium have? 2. So that must mean if it's going to be neutral, it has to have 2 electrons. Well, the rest of the noble gases have 8. Helium can't do that because it only has 2 protons to begin with. So that's why helium is not attached to the rest of the noble gases. They do here on your tables, but that's why on some you see that helium is not attached with the rest of them. Okay. You need to choose. I would go with this one. Okay? But if you're looking at that one, that's just fine too. That's not a problem. But once you get to have a really good understanding of this, then you really don't need to be utilizing this slide rule much anymore. But again, it's still just a tool to help you navigate through this chapter. Because now, when we look at this right here, okay, or what does it say right there? Periods, okay? So that's what we're talking about. These are all your periods on the periodic table, okay? So we got 1, 2, 3, and 4, and 5, and 6, and 7. That's where these numbers are coming from. This is trying to illustrate the whole periodic table in just one simple, concise slide rule. Because as you look at the diagram on figure 16 on page 111, if you're good at spatial orientation, in other words, analyzing something in 3 dimensions in your mind, what does figure 16 resemble? What do you think it looks like to you? What happens if you flip it upside down? What do you suppose it kind of resembles? Yeah, it's the slide rule right here. Okay? But to me, this was, they might even have a picture of the slide rule somewhere in this textbook, but yeah, on page 116, they have, it's figure 19 that has that same thing, okay? It just says follow diagonal arrows from the top to get the order in which atomic orbitals are filled according to that funny term we said yesterday or 2 days ago. AFABU. The AFABU principle is commonly known as the slide rule. Another term you're going to have is something called Hund's rule. Well, we knew it as something else in physical science. It was something with a bus. And with that, you had a bunch of these little lines like this. Like, for instance, that would be incorrect. Yeah, we did. Sure. Okay. Because what we mean by that is if this is the, if we did the 1s and this is the 2s and this is the 2p, okay, what that meant is all of these seats on the bus, or the bus seat You don't remember the bus seat rule? Sure we did. Okay. Well, I don't know the specific time. I got a file cabinet that probably has papers that say otherwise. Yes. Okay. But what that means, notice I had an arrow here. These arrows denote electrons. Okay? What that means is in the 2p block that all of these seats need to be filled before you can start pairing them up. Yeah. The bus seat rule. We will. We will. Don't worry about that. Okay. Okay. Now, back to page 110, when you look at principal quantum number 2, okay, the next column over it says subshells in main energy level. Has what and what in the second energy level? What letters? S and P. So that's where we see S and P now. Okay? So then, okay, we go over, skip 2 columns, says number of electrons per sublevel. Remember, the S block can hold how many? 2. Now, if you look at over there on the table on the wall, or this one, the P block, which is way over here, how many columns does this have? It's got 6. So it's not just a coincidence that when you look on this table, on table 2, on page 110, it's got 2 and 6. So then the second energy level can hold a total of how many? 6 and 2 gives you 8. Okay? So one of the aspects that some students choose to do, others choose not to do, you need to decide which path am I going to choose. What that means is we know that the S block can hold 2, S block can hold 2, the P block can hold 6. Okay? Do we see a repeating pattern here? The S block can hold 2, the P block can hold 6. Okay, we're going to stop there. Okay? We're sort of. Not yet. The slide rule. Yep. So now, when you look at the principal quantum number for number 3, oh, I remember. I think we did these, but you weren't assigned the quantum numbers. That's why. Okay? You did configurations. You might not have done this in physical science. You might be right. We'll come back to that in just a moment. Okay, so the principal quantum number 3. How many letters are in the third energy level? 3. S, P, and D. S, P, and D. Now you skip 2 columns and number of electrons per sublevel. S is still 2. P is still 6. So what can D hold? 10. So 10 would go here. All right. So the first energy level can hold 2. The second energy level can hold 8. The third energy level can hold how many? 18. Okay. So now this repeating pattern goes down to the 4th energy level. Okay. How many letters are in the sub-levels in main energy level? How many letters? There's 4 of them. S, P, D, and F. Okay? Go all the way over to number of electrons per sub-level. Okay? S is still 2. P is 6. D is still what? 10. And F can hold how many? 14. Now, these are just saying how many they can hold. It doesn't necessarily mean you're going to fill them every time. Yes? because notice on page one, it stops at 4. Really, it could go on to number 5, okay, and it'd still just be S, P, D, and F, just like what we see here. So then you go on to number 6, and it would just be these 3. But once you start adding up all of these numbers, you're going to get up into 100 and what does it stop at? 103 is Lawrencinium, I think. 109. Okay. So, oh, I was looking down here, but yeah, these are synthetic elements. So yeah, it does go. There's actually some more down in here. I think there's mountaininium, or it's M and T, I believe. What's that? Oh, okay. So, yes, there are more elements on the table since that one was printed. We've got, let's see here, that stops with, those are all 3-letter elements. 104. Well, they've kind of moved them over, looks like. But we do not get down into that level, okay? We will not do these elements down here. Will we get down into the F sub-level? Definitely. We still get this big. We still may even get down into these two as well. So these numbers do get pretty big, okay? So just keep in mind, we got 2 columns for the S block. That's where that comes from, okay? 1 and 2, okay? There's 6 columns for the P block. Here they are, 3 through 6. We've got the D block. That's between my fingers here and here. That would be, there's 10 columns there. And then as you look at the bottom, there are this many associated, and there are 14 of them. So when you look at that, you could go on and go ahead and put these 14s in there should you choose to do that. So that's just a breakdown of how you use this table. You're going to have to use both of them at the same time. And again, this is just a tool to show you how it is that they fill, okay? And in the order that they do so. Doing it for bore models, which is this, configurations, which is just a linear depiction of that, and then orbital diagrams where it has the little arrows pointing up and down. We may not have done that and when you were a freshman, okay? So that's just, again, just a brief introduction on how to use that table. So whether you choose to, you can write the rest of these numbers in if you want to. Otherwise, just leave them blank. To me, we've done this enough that I don't like to put the numbers in there, okay? But, again, what this just tells you is that the 4P block can hold 6. It doesn't necessarily mean that all 6 of them are in there, okay? So, I think we will go ahead and do a bore model here. We've done one with copper already, so perhaps let's show how they are filled up. How about a middle of the row? How about silver? Okay. Well, why is silver Ag? Yeah, argentum. Yeah. See, you learn something every day. See, how would you know? Maybe I'm making that up. Argentum. That makes sense. It's got an A and a G in it. You know, see, I can't think quick enough. I should have said it was agriculture. Yeah. Yeah. But, you know, it's, gold is just so, silver is just so friendly. It's always waving at gold, and when it does that, it's just saying AU, AU. You're shaking your head. These elements, they got their own personalities. Silver says to gold, AU. See, I even waved as I went by, you know. Okay, so let's follow our slide rule for the element silver. I think I'm going to, it's a little brighter on this side. Maybe it's because we got the lights, or maybe because our class warrior just beams with energy and light. Oh, that's not it? Well, what else might it be? Okay. All right. So, what is the atomic number for silver? What is the atomic number for silver? 47. Okay. So, if you're just joining us, you might not want to. I should have told you not to write them numbers in there, but we'll make sense of that at a later time. It's all in the video that we've gone over just now. Okay. So following our slide rule, okay, so on your table, we go up to the top of the first energy level, okay, there's our first energy level, the S subshell. It can hold how many? 2, so that's telling you that it can hold 2, okay. The energy level, yes. Yep. So now you went to the top of this slide and you go down. This is saying we need a new energy level. So the S subshell can hold how many? Okay, so that's where those 2 are. You go to the top of the next slide. We're still in the same energy level, the second one. And how many can the P block hold? Okay, so the slide rule is telling you that as you go down, what is this telling you you got to do? We need another energy level. Okay, so what we see happening is, what do we put up here? 2, because it's telling us that the S sub level, it can hold 2. So we go to the top of the next slide. Are we in a new energy level? No, we're still in the third. It can hold how many? Do we put them all in there? Yeah, because these numbers added up together won't equal 47 yet. Okay? Now this is the tricky part. This is where the slide rule or Afabu principle makes corrections for you. Okay? Because what it's saying is after the 3P, what is that telling you? We need to make a new energy level. And how many are we going to put in there? Okay, so now we go to the top of the next slide. Now, where are we? The third one, which is right here. How many can this one hold? Do we want to do that? Okay. Are you sure? That works. That's right. That's right. Okay. So now we keep going. What's this telling you? Which energy level? Right below 1, 2, 3, 4. Here is our 4P6. Okay. So what is this telling you? Okay. So 1, 2, 3, 4. Here's our fifth. And we're going to put 2 of them in there. Now, what is this telling you? Okay? And, okay? I'm just doing what we're told. So does that have 8, 9, or 10 in it? Is that what we want? No. We want how many? 9. Okay? So, that's why if you're putting these numbers in there, that's only a reminder of telling you how many it can hold. Because if you put them in there and you don't realize that, it's a bad habit. You're going to look at these and say every time we're going to put 2 in. Every time we're going to put 6. Every time we're going to put 10. We already see that is not the case. For this, we don't want 10. We want 9. So if we change that back down to a 9, right? There's a couple ways that we would know that. Look at your table. Find the D block and count from left to right in the D block only what column is silver in. It's in the 9th column, and that's where that number comes from. Okay? So that's how you use, that's why we say eventually you won't even be using this anymore. Once you get a good understanding of how the periodic table works, you won't need this anymore. You'll just have the table in front of you. Okay? So whether you choose to write these in here, that's entirely up to yourself. Okay? So I believe the only thing that can be a little tricky with this, and we're gonna have to do this with practice, is that as you're looking at this table, whether it's this one on the wall or the one that you're holding in front of you, notice that it goes 4S2, but this is not 4D. This is which D? No. This whole block here. It's the D block, but which energy level is this? The slide rule is telling you. No, it's not the 4th. This is 4S2. What comes after 4S2? 3D10. So that's why the slide rule makes that correction. It's another bad habit. Don't fall into that and say, oh, well, since it's silver, that last electron must be in the 5D. Did we get to the 5D? No, we stopped at the 4D. So the only thing you got to make sure of is that this is 4S2, this is 3D10, 5S2, 4D10, 6S2, 5D10, although I skipped some of the 4Fs in there. But that's what this is trying to tell you. The only tricky part about that and how the slide rule makes that correction is that you're going from 4S after you goes potassium and then calcium. Calcium would be full with 2. Then you go back down to the 3rd, and it's the D block, but it's 1 less. That's the only problem that students may have, your young men and women, with this. But you can't move scandium and yttrium and the La and AC up 1. Why can't you do that? Because what's calcium's atomic number? What's scandium's atomic number? You do not want to have 21 coming after 12, do you? No, it would be out of place. Okay? So that's why this slide rule was then developed. Okay. I hope you don't feel overwhelmed. Is anybody totally lost right now? But should that be, I don't quite get it, you can maybe go through this again, and hopefully it helps explain what we've done. We'll pick up more examples of this tomorrow.